So I teach a module called Sex and Social Behaviour, which equates to kind of advanced behavioural ecology, really, and looking at all of the evolutionary factors that might affect the evolution of sexual behaviour and reproductive behaviour, but also social behaviour. My particular interest is in parental care behaviour, and we spend quite a lot of time looking at how that fits in with sexual behaviour and reproductive behaviour generally, and how it also leads on to the evolution of social behaviour. And I also teach a module called Insect Biology, which is that was like being given a blank sheet on which to draw your vision, it's absolutely wonderful module to teach, because I just get free rein to go over the craziness of insect biology. At the beginning of every lecture, I sound a bit like a stuck record. At every single lecture, I'm like, this is my favourite lecture. No, this is my favourite lecture to teach. But I think, to be perfectly honest, my favourite lecture is the predators and prey one, where we explore the different weird adaptations insects have to catching and killing prey, but then also their adaptations for defences. And it's in that lecture that we cover crypsis, insects that can so perfectly blend in the background that you would never ever see them, and mimicry, insects that have evolved to look like other insects. But in terms of a fact that everyone should know, in all of their grim weirdness, we go through a bunch of kind of really bizarre examples of insect predators, and I wonder if anybody watching knew that there was a beetle whose larva is adapted to catch, kill, and eat frogs. It's called a pomis. It's so hard, it's so heavy metal that there's even a heavy metal band named after it. So what happens is the larva wriggles around on the ground looking like a vulnerable worm, at which point a frog thinks, oh, I'll have that, and so hops over, shoots out its tongue, as a frog does, at which point, quick as lightning, the larva grabs onto its tongue with its jaws and is swallowed by the frog, but it won't let go of its tongue. And the larva proceeds to begin to eat the frog from the inside out. And we have these, it's such a grisly but gruesomely awesome tale, where the larva just begins to eat, and it just pushes all of these weird buttons. Like the idea of an invertebrate eating a vertebrate is something which is inherently grim. I think that's part of why we have a fear of spiders, but this is just a particularly weird example. And when they get to adults, they're no better either. The adults are also adapted for eating frogs. They grab onto the outside of frogs rather than the inside of frogs, but still, they hang on for dear life, and then they just begin to eat the poor thing alive. So that's one particularly interesting insect predator that people should know about. As I said, I'm interested in parental care behaviour, both kind of great big patterns in how things evolved right from the ancestral insect, but also like right now I'm doing some I find it really fascinating looking at the way that mothers provision offspring, and bees are really cool for that because the offspring develop only on provisions given by the mother, and I'm looking at how mothers ensure that baby bees get a balanced diet. And right now, we're focusing on the babies and seeing whether they are able to balance their own diet. What we do is we allow bees to breed, and then we raise them. So we let the mother bees make a nest in the field, and then we take the nest into the lab, and we swap the pollen ball that the mother has given to the baby bee. Normally, she would put a pollen ball into a little cell, drop an egg onto it, and then seal it up and leave. This is a solitary bee. It's not a social honeybee. And then she would do that about 10 times, and that would be her nest. And so we take the cell into the lab and we swap the pollen ball for one which we've devised ourselves, like an artificial diet. And we can compose it of different amounts of protein and carbohydrate and fat to see how the babies, the developing larval bee, reacts to different compositions of food. We found that quite surprisingly, they have this kind of target amount of carbohydrate, and they'll eat whatever you give them. They'll eat until they get the right amount of carbohydrate, and then they'll stop, which is very interesting behaviour. And that's what we've been doing for the past few years. And now what I'd like to do is to fill in the other side of the equation, which is, can mother bees compose the right diet for their offspring? That's what this flight cage is about. So what we'll be doing is we'll be attempting to get the mother bees to nest inside the cage, at which point we can control what kinds of flowers we give them, and what composition of pollen critically they have to choose from, to see if we give them a really protein rich one and a really protein poor one, like one which is high protein and low carbohydrate, or one which is high carbohydrate and low protein. Can they kind of strategically balance mixes of those two to give to larvae so as to balance their diet? Or do they leave it up to the larvae to balance their own diet? Those kinds of questions, which I think are really, really cool. What am I most excited about at the moment? So I'm Programme Director for Zoology, and Zoology is undergoing some changes, just as lots of other programmes are right now. And one of the things I'm most excited about for Zoology is the fact that we are bringing in some new modules, vertebrate zoology and invertebrate zoology. So vertebrate zoology is going to be like a tour of the evolution of vertebrates, including all of the things that you think about when you think about the most exciting vertebrate evolution, like dinosaurs, and the evolution of the crawling fish crawling out onto the land, evolution of tetrapods, and I believe we're going to have some really cool stuff there. The person teaching that module is an expert on the evolution of shape and form, and I believe we're going to have some quite cool material on the evolution of dinosaur skulls. Well, I always say that whenever anyone asks me that, my first thought is, why would you ever not? Like, it's so everybody is a zoologist, really, from when you're a baby. Like, every child, can you think of a child that's not interested in animals, that's not interested in dinosaurs? Your very first book is one of, full of animals. And I've got 3 kids myself. Every one of them is obsessed with animals. And so it's a question of when did we lose? Like, people who don't want to be zoologists are the ones which, they must have lost it somewhere. It's a question of keeping that flame alight. It's something which everybody has, and I think it's important to keep that kind of sense of awe and wonder at the natural world.